Now let's look at an example of a binomial distribution and a binomial problem. First, though, forget that you know that this is binomial. Let's see if we can see in the problem description of why it's binomial. So restaurants closing. Please take a moment, pause the video, and read over the problem example 8.2. So we have a probability that 3/5 of all new restaurants close or change ownership within the first 3 years. Okay, that's good to know. There's no indication that the probability, if you read the rest of the problem, is changing. So the probability is constant. That's good. Suppose that you randomly select 20 new restaurants and let X denote the number of those 20 new restaurants that are still in business with the original owners after 3 years. So is there any indication that one restaurant closing affects another? No. So that looks like they're independent. Probability of success here is we're looking at X is the number of new restaurants that are still in business. So we're looking at still in business being the success. And you either are in business or you're not in business after the 3 years. So there are only two possibilities, two outcomes. All right, so it's looking good. So describe the probability distribution for X. X, as we've talked about, is given by the binomial distribution, or you can write out binomial if you like. I'm going to write out n equals, just so we're clear here. 20 is the number that we're looking at, and the probability is 2/5. X is the number of restaurants. P is the probability of still in business. This is our success in this case. And that all that information is given in the example, in the problem statement. Now, how many of these 20 new restaurants do you expect to still be in business with the original owners after 3 years? And it also asks to interpret what the word expect means in this sentence. When we think about expect, we think about what's going to happen on average in the long run. So that's that E of X. Now, a lot of times what students want to do is they want to write out all the entire probability distribution table, but you don't have to with binomial. Remember, we have that formula n times p. So 20 times 2/5 gives us 8. How would we interpret that? Please pause for a moment and think back to what we've done in the past in terms of expected value and see if you can come up with how we would interpret that. So hopefully you remember that when we talk about expected value, we're thinking about in the long run, out of many samples of 20 restaurants, it's not just one time, it's many, many times that we would do this. We expect 8 on average to still be in business with the same owners 3 years later. Does it matter if you have the exact same words? No, but as long as you have the idea it's in the long run, many samples, what value we expect on average, and the conclusion, or excuse me, put it in context, then you're good. The next part asks to calculate the standard deviation of the number of these 20 new restaurants that are still in business. Once again, since we know it's binomial, it's fairly simple to calculate. It's the square root of n times p times 1 minus p. So we're going to get the square root of 20 times 2/5 times 1 minus 2/5. You may be like, well, I already knew it's 3/5, and that's fine. Just make sure that these two total to 1. When you do that calculation, you're going to get 2.19. Now it says here, determine the probability that X equals its expected value. So we want to know what the probability that there are exactly 8, stay open because 8 is our expected value. Does order matter in terms of whether we talk about restaurant 1 or 2 or 2 or 1? No, being both in business. Let's say for that, or out of business, no. But we want to say we've got 20, choose 8. Okay, because remember, order doesn't matter. 2/5 stay in business. The remainder have to close for this to work. Remember, 8 plus 12 has to total this 20 here. the probabilities have to total 1, and this is the number of successes, and there we go. When you multiply this out, you get 0.178. These last two, you would need some form of technology. And on an exam, I would expect you to more just come up with the general equation, but you would not have to, I would not expect you to solve it. Determine with technology the probability that at most 5 of the new restaurants are still in business. Let's see. X has to be at most 5. So we're going to include that 5, but we don't want any more than 5. So less than or equal to 5. So P of X equals 0 plus P of X equals 1 plus all the way up to P of X equals 5. Now, a lot of calculators will do this for you. You can use Excel or Google spreadsheets to do this. We're not going to spend time in this class doing it, but it actually, you'd think that, well, what's that probability going to be? Could we predict it right off? Probably not, but we've got 0.126. What's the probability that, in this case, at least 10, so we want at least 10, so 10 or more, are still in business? There are different ways to calculate this. We could use that complement rule. Sometimes that's easier given the way that the calculations are done. But I just want to show you that you can get it using I just wanted to let you know, I should say, I'm not going to show you that you can get it with technology, and that's 0.245. If I did each of those individual probabilities, P of X equals 0 plus P of X equals 1 plus P of X, and did it all the way up to 20, P of X equals 20, what would the probabilities have to total? And hopefully you think, well, they would have to total 1 to be a valid probability distribution. This is more just showing you in general that this can be calculated, but that we would need to use more than the tools we're using in this class. Or it would take a very, very long time to do it manually.